Antimatter is one of the most fascinating and mysterious substances in the universe. It's the mirror opposite of regular matter and holds incredible power, but it's also incredibly rare. From theoretical concepts to practical applications, antimatter continues to challenge our understanding of physics and the cosmos. Here are the top 10 mind-blowing facts about antimatter and its role in the universe. 1. Antimatter is the opposite of matter. Antimatter is composed of particles that have the same mass as regular matter particles but with opposite charges. For example, the antimatter counterpart of the electron is the positron, which has the same mass as an electron but a positive charge. When antimatter and matter come into contact, they annihilate each other in a burst of energy. 2. Antimatter and matter were created together. During the Big Bang, both matter and antimatter were produced in equal amounts. However, for reasons that scientists still don't fully understand, the universe today is made almost entirely of matter, with very little antimatter. This imbalance remains one of the greatest mysteries in cosmology. 3. Antimatter is extremely rare. Although antimatter was created alongside matter at the birth of the universe, almost all of it seems to have disappeared. Today, antimatter is extremely rare and can only be created in small amounts in particle accelerators like the Large Hadron Collider, LHC. Naturally occurring antimatter can be found in cosmic rays, but it's rare and difficult to detect. 4. Antimatter could be the key to unlocking energy. When matter and antimatter collide, they annihilate each other and release an enormous amount of energy. This process is far more efficient than any chemical or nuclear reaction we know of. If scientists could harness this energy, it could revolutionize power generation. However, creating and storing enough antimatter for practical use remains a significant challenge. 5. Antimatter is already used in medicine. Despite its rarity, antimatter is used in everyday technology, most notably in medical imaging. Positron emission tomography, PET, scans use positrons, the antimatter equivalent of electrons, to detect diseases, including cancer. In this medical application, antimatter helps doctors visualize processes inside the body with high precision. 6. Antimatter could be used for space travel. In theory, antimatter could be the ultimate fuel for space exploration. Because matter-antimatter annihilation produces so much energy, it could power spacecraft capable of traveling vast distances at high speeds. Scientists are researching this possibility, though the current challenge is producing and storing enough antimatter for such purposes. 7. Antimatter can be found in thunderstorms. Recent studies have shown that antimatter is produced naturally in Earth's atmosphere during thunderstorms. When lightning strikes, it can create positrons that are detected by spacecraft and ground-based instruments. This discovery provides a rare glimpse into the natural production of antimatter on Earth. 8. The mystery of the missing antimatter. The antimatter problem is one of the biggest puzzles in modern physics. If matter and antimatter were created in equal amounts after the Big Bang, why is the universe dominated by matter? Scientists theorize that some unknown process caused a tiny excess of matter to survive, while most of the antimatter was annihilated. Understanding this could reveal new insights about the origins of the universe. 9. Antimatter has been detected in space. Antimatter isn't just a theoretical concept, it's been detected in outer space. High-energy cosmic rays striking Earth's atmosphere sometimes produce antimatter particles. Antimatter has also been detected near black holes and pulsars, where intense magnetic fields may create antimatter in large quantities. These cosmic antimatter sources offer clues to how antimatter behaves in the universe. 10. Antimatter could reveal new physics. Studying antimatter may unlock new laws of physics. Researchers are investigating whether antimatter behaves exactly like matter or if it has subtle differences that could point to new physics beyond the standard model. Experiments are ongoing to compare the properties of antimatter and matter, and any difference could revolutionize our understanding of the universe. Antimatter remains one of the most mind-bending concepts in physics. Its rarity, immense energy potential, and role in the early universe continue to intrigue scientists. While much remains to be discovered, understanding antimatter could answer some of the biggest questions about the universe's origins and future.